Hello there. Welcome to this video on working with sensors. In this video, we're going to take a look at the functionality, circuit setup, calculations, code, and of course, demo of light and motion sensor. Alright, let's get started with the LDR. Now, LDR is a light dependent resistor. Now, you can think of it as a big resistor. The property of it is that the resistance is inversely proportional to the ambient light. So if there is more light around the LDR, then the resistance is going to be less. And if there is very less light around the LDR, then there's going to be very high resistance on the LDR. Now we want to measure the change of voltage when the resistance changes. And this change of voltage is measured across a voltage divider point. Don't worry about it. We'll take a look at it now. Now let's take a look at the circuit. So you have an Arduino Uno, we have a breadboard, you have an LDR, you have a 10k ohm resistor and 3 jump wires. Alright, perfect. First connection, 5 volts to your LDR's one end. Second connection, the other end of the LDR to the one end of the resistor. Third connection, the other end of the resistor to your ground. Perfect. Now the voltage divider point is where your resistor meets your LDR, and that is going to be connected to A0. That is going to be our analog pin where we're going to be measuring the voltage. Perfect. Now we want to be understanding mathematics behind it. Now let's take a look at some equations. First is the equation to measure the voltage across the voltage divider point is this. So let's call it V0, which is your voltage across point A0, which equals to VCC into R1 divided by R1 plus the LDR's value. Now this LDR's value is what is going to change depending on the ambient light. For the case 1, we're assuming that the ambient light is less, so that's going to be a bit dark. Alright, now when it is dark, the LDR's resistance can be very high. So for example, we're assuming that to be 50 kilo ohms. Now R1 is going to be 10 kilo ohms, which doesn't change. VCC is going to be 5. Perfect. Now if you put all of that in the equation, V0 is going to be 0.83 volts. So you understand that when the resistance is high, the voltage is less. Alright, now if you do the same for when the ambient light is bright, then we can assume that the LDR resistance drops and that becomes 6 kilo ohms. Now if you put that in the equation, then you're going to be getting 3.125 volts. So then you understand that when the LDR resistance goes down, the voltage goes high. Alright, now how is this going to be understood by your analog pin? Let's see that. Now your analog pin reads values from 0 to 1024, and this is split across 5 volts. So when the output is something like 800, that means your voltage is in between 3 and 4. If your output says 400, then that means your voltage is in between 1 and 2. Just keep that in mind. This will make more sense when you see this in action. Now let's take a look at the code. The first thing is I'm creating an integer called pin and initializing it to value 0, and this is going to be our analog pin A0. Alright, next is another variable called the LDR value. This is going to store our LDR value temporarily for us. Alright, perfect. Next is in the void, we are initializing the serial and we are punching at 9600 baud rate. In the main loop, first thing is you're going to read the value across the voltage divider point on your pin A0 by calling the function analog read, and we already given the value of pin as 0, so 0 is going to be substituted here, and that value is passed on to the integer LDR value. Now we're printing some basic text called reading, and we're printing the LDR value. Then what we're going to do is we're going to print some more information depending on how much light is around it. Now we're saying that if the LDR value is less than 100, then print pitch dark for me. If the value is less than 400, say low light, and so on. And we're delaying by 1 second so that the measurements are more accurate. Make sure your tools are selected, make sure your comma is selected, and all that is good to go. I'm directly going to say upload because it's going to compile and upload anyways. This is going to take a second. So it's uploading now, and very good. Now I'm going to open my serial monitor. So you can go to tools and open your serial monitor, or you can also click serial monitor from here. All right, let's do that. There you go. Make sure you are at 9600 baud. If you're not, you're going to see some gibberish here. Okay, so it started punching out our information. So it's saying reading 963, bright light. Now what I'm going to do is I'm going to switch off my light just for a bit. Now you see that the light is less. Also you can see in the camera that the light is less, and it's punching out 529, 545 and so on. I still have some background light, so that's why it's still measuring some light. Perfect. So that's how it works. Go ahead and give it a try. Let's take a look at the motion sensor. This is very useful anytime you want to detect a motion of human beings, any object movement. This will be the 2GO sensor. This is a pyroelectric sensor. It basically detects your IR radiation in an ambient place, and it detects the change of that specific radiation. If there is a change, then it gives a high output. The detection range is about 20 feet. You can give it about 5 volts, 12 volts, and it's quite stable. One thing to keep in mind is this does not penetrate any walls. So if you want to detect the motion outside a wall, this is not going to be the one for you. Alright, let's take a look at the circuit diagram. It's very straightforward. You're going to have 3 leads. So one lead is plus, one is minus, the other one is the output. So the red one is plus, it goes to 5 volts. The black is ground, goes to ground. And the yellow is the output, which is going to pin number 2. And that's exactly what we've done. In my assembly, I have used a breadboard just to make it a bit more easier for us. Alright, let's take a look at the code now. There are a lot of codes out there to read the motion, one by Adafruit, one by SparkFun. Everybody has their own code. But let's see what the pin is doing when the motion is around it. And then once you understand this, then you can use this to manipulate it and use it to your application. Alright, perfect. For that, I'm going to go to my examples. I'm going to go to basics and pull up my digital read serial. So basically there's a program already written for you, and make sure that the pin is 2. So in this case the push button is 2, and basically in the setup you're initializing the serial, you're initializing the pin mode to input. That's what we want. In the void loop, you're basically reading the value of that pin number 2 by using a function called digital read, and you're printing it to the serial. You're giving a 1 microsecond delay. Let's go ahead and give it a half a second delay. Alright, now let's go ahead and compile it. Alright, that's it. Pretty good. So let's go ahead and open the serial real quick and let's see what's happening. So it's punching 0, 0, 0, 0, 0. Now I'm going to move my hand around the motion sensor. Now you see that I moved my hand around the motion sensor, and as long as it's detecting a change in the IR radiation, it's punching out 1. It punched out 1 for a couple of seconds, and then it started punching out 0 again. So you can change these values. So you can change the delay, you can change sensitivity and so on. So those things are available on your sensor. Once you understand this, you can use this to do whatever you like in your application. Whether you want to send a value to a platform, or whether you want to turn on an LED or a phone call, whatever that may be. I hope you learned a great deal in section 2. Now you know a little bit more about how the internet works. You're now familiar with the most used or commonly used IoT communication protocols. Now you started getting used to the hardwares used in IoT devices. We have introduced the Arduino Uno, which is a game changer in learning IoT. You already started to work with the Arduino Uno. You know how to light an LED. Somebody said that if you can light an LED, you can do anything. That's actually true. You also introduced the game-changing ESP8266 Wi-Fi module. You also set it up and tested. You also worked with sensors like light and motion. All in all, it's a great starting point to go ahead and build IoT solutions and devices. In the next video, ThingWorx development process with example.